Good morning, everyone. I am going to explain the satellite is a man-made object launched into the space to orbit around the Earth, Moon, Sun, or other bodies. Examples of satellites are weather satellite, communication satellite, etc. The basics of satellite communication includes two types of segments. One is space segment and earth segment. In earth segment, we have a ground station for transmitting signals, and in earth segment, we have satellite orbiting around the earth. Signal is transmitting between the earth station and the satellite. There are different types of satellites. It is broadly classified into two types: natural satellite and artificial satellite. The example of natural satellite is Moon. Artificial satellites are further classified based on orbiting the Earth and based on application. And based on the orbiting of the Earth, it is classified into geostationary satellite, medium Earth orbiting satellite, low Earth orbiting satellite, highly elliptical orbiting satellite, polar satellites. Based on application, it is classified into remote sensing satellite, meteorological satellite, communication satellite, weather satellite, etc. What is an orbit? Satellite move in a path around the Earth is called an orbit. The orbits are classified into three types. In first type, based on inclination, it is classified into equatorial orbit satellite, inclined orbit satellite, and polar orbiting satellite. Based on altitude, it is classified into low Earth orbit satellite, that is LEO, and second is medium Earth orbit satellite MEO, and high Earth orbit HEO. The LEO satellite orbit from distance from 0 to 2000 kilometer, and medium Earth orbit from 2000 above 2000 kilometer, and high Earth orbit is approximately at a distance of 35,786 kilometer. So based on shape, it is classified into circular orbit and elliptical orbit. So we have another orbit called geosynchronous orbit. The satellite in these orbits circle the Earth at the same rate as the Earth spins. It normally takes 23 hours, 56 minutes, and 4.09 seconds to make one complete revolution around the Earth. So the approximate distance of this satellite is 35,790 kilometer above the Earth. So we are going to see some basic laws that is used in the satellite communication. Kepler's law. Kepler's first law is also called as law of ellipses. What it tells is the path of the planet about the sun is elliptical in shape, with the center of the sun being located at one of the focus. So it also states that path followed by the satellite around the primary will be an ellipse. An ellipse has normally have two focal point F1 and F2. The center of the mass of the two body system, termed as barycenter, is always located at one of the focus. So one important terms regarding the Kepler's first law is eccentricity. Eccentricity is represented by E. E is given by square root of a square minus b square divided by a, where a is nothing but semi-major axis and b is nothing but semi-minor axis. And the value of eccentricity is always between 0 to 1. Since satellite is revolving around the Earth in the elliptical orbit, there are two different axes called major axis, and which is in the horizontal direction, and minor axis which is in the vertical direction. So Kepler's second law states that for equal time intervals, the satellite will sweep out equal areas in the orbital plane, focused at the barycenter. So the Kepler's second law is shown in the first figure. In the first figure, satellite is covering the distance a1 and equal time interval. It travels the distance s1 from this point to this point. So this is the satellite. This is the Earth. The satellite is revolving around the Earth, and time t time. So for example, in 1 second, the satellite moves this point to this point, and the area of coverage is a1, whereas when the satellite travels from this point to this point in the same 1 second, it covers a distance, small distance only. And if you see the area of coverage, it is a2. As per the Kepler second law, a1 is equal to a2. So Kepler's second law is also called as law of equal areas. So this is Earth, and this is the satellite. Blue one is satellite, and these dots shows the different points. And see this area different. This area is in different shape. Even though it is in different shape, it area is equal. All is having equal areas. Here also these segments are different shape, but if you calculate area, the area is similar. This is Kepler's second law. Kepler's third law states that the square of periodical time of an orbit is proportional to the cube of mean distance between the two bodies. The mean distance is equal to semi-major axis A. So, for an artificial satellite orbiting the Earth, Kepler's third law can be written in the form A cube, where A is the semi-major axis and N is nothing but the orbital period. So, our square of orbital period is inversely proportional to the cube of mean distance between two bodies. Mu is the constant, proportionality constant. The value of mu is 3.98 into 10 power 14 meter cube per second squared. If we want to write n in radians per second, the orbital period p is given by 2 pi by n. So another scientist called Newton, he devised three important laws. So that is also used for satellite communication. Newton's first law is also called as law of inertia. Every object in a state of uniform motion tend to remain in the state of motion unless an external force is applied to it. Or an object at rest always stay in rest, and object in motion always in motion unless otherwise some external force is acted upon it. So this is shown by the example given here. So the body is motion. When there is an external force, there is a change of state. The second law states that force is equal to F is equal to m into A. So m is the mass, A is the acceleration, and F is the force. The second law states that acceleration of the body is directly proportional to the magnitude of the force and inversely proportional to the mass of the object. That is A is equal to F by m.